Today's lesson is on the quadratic formula. Now the quadratic formula is found by using completing the square on the standard form of a quadratic equation, ax squared plus bx plus c equals 0. When you do that, you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, understand, you're going to want to memorize this formula right here and how it applies to ax squared plus bx plus c. It's going to come in very handy for solving quadratic equations. So let's start with a quadratic equation. X squared plus 3x equals 2. The first step is to write it in standard form by moving the 2 to the other side. Then we can plug them in to the quadratic formula, this thing right here. So it helps to memorize that and save yourself some time later. So in this case, x equals, our b is 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is negative 2, so the signs always go with them, over 2 times 1. Then it's just a matter of simplifying. Get negative 3 plus or minus the square root of 9 plus 8 all over 2. And so we get, in simplest form, x equals negative 3 plus or minus radical 17 over 2. So we have two answers there. I want you to notice something. Because this number here was positive, we have two real number solutions. If it had been a negative, we'd have two imaginary or complex solutions. And if it was 0, we'd have only one solution. So in the next equation, let's just bring that quadratic formula back. We have 25x squared minus 18x equals 12x minus 9. So we start by moving everything to one side. Then we plug it in to our quadratic formula. So we have x equals negative 30, because b is negative 30, plus or minus the square root of b squared, so that's negative 30 squared, minus 4 times a, which is 25, and c, which is 9, all over 2 times a, which is 25. So we have 30 plus or minus the square root of 900, and 4 times 25 times 9 is 900, all over 50. So what you notice is we're going to get 0 underneath the radical, which is just going to leave us with 30 plus or minus 0 over 50, which is 3/5. So since that became a 0, we had one real solution. Sometimes we won't have real solutions. Sometimes we'll have complex ones. In the third example, we're given negative x squared plus 4x equals 5. Let's move everything to one side. Gives us negative x squared plus 4x minus 5 equals 0. So we plug it into our quadratic formula. X equals negative 4 plus or minus the square root of b squared minus 4 times a, which is negative 1, and c, which is negative 5, all over 2 times a, which is negative 1. So we got negative 4 plus or minus square root of 16 minus 20 all over negative 2. Got to continue to simplify here. We got negative 4 plus or minus the square root of negative 4. That simplifies to negative 4 plus or minus 2i over 2. And when we divide that by 2, we get negative 2 plus or minus I. So notice, because this was negative here, we get two complex or imaginary solutions. So that's how we use the discriminant. The discriminant is simply the part underneath the radical, b squared minus 4ac. If that's positive, then we have two real solutions. If it's equal to 0, we have one real solution. If it's less than 0, okay, we have 0 real solutions, or too complex. So we can use this in an expansion of our launched objects. We did dropped objects before when the initial velocity was 0. Now we're going to throw in an initial velocity for something that's been either thrown down or up or projected with something like a bow and arrow or a baseball or a golf ball. So in example 5, a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground. That's our initial height. And has an initial velocity of 40 feet per second. That's our v0. That's the new part today. The juggler catches the ball when it falls back to a height of 3 feet. So the question is, when will it reach a height of 3 feet? So we want to solve this equation using quadratic formula. First we move the 3 to the other side. Now, I want you to pause the video, work this through with the quadratic formula, and then unpause the video and see how we did. Okay, so if we plug this into the quadratic formula, we have t equals, instead of x, negative b, which is 40, plus or minus the square root of b squared, that's 40 squared, minus 4 times a, which is negative 16, times c, which is 1, all over 2 times a. Now, I want to point out something real quick here as we see the big numbers under the radical. Since this is a real-life situation, we should expect to get at least one real solution. If we come up with complex solutions, then we've got an issue. It's like saying that we could not have thrown a ball from 4 feet above the ground at an initial velocity of 40 feet per second. Doesn't quite make sense. So we got to be able to come up with some answer here. So continuing to simplify gives us negative 40 plus or minus square root of 1600 plus 64 all over negative 32. So we have negative 40 plus or minus radical 1664 over negative 32. This is a good time to use your calculator to get a decimal answer because we're looking at a practical situation. Just be careful how you plug it in. It's helpful to put your whole numerator in parentheses. Do the plus first, then go back, bring up your last entry, and change that plus to a minus. When we do that, we should come up with negative 0.025 and 2.5. Now, having the ball caught before he throws it, that doesn't make sense. I mean, you can, with juggling it kind of does, but that's not the answer we want because we're looking for after he throws it. So this is the solution we're looking for, 2.5 seconds. If you have any questions, feel free to ask. If you need something clarified, you can go watch the video again. If not, you can start on your homework.